All right, so here we are moving along in our world of division, right? We're figuring out some different things and different techniques, and we've been working on many. Um, Today we're going to talk about this idea of partial quotients, and before we get into that, I just break down what that really means, right? If we look at that first word, part, that is partial, and that's really what it means. It's just like a part, right? And then quotient, if you remember, is the answer to a division problem. So what we're going to be doing today with partial quotients is solving division problems in parts, right? Like in parts and chunks. And really that's all partial quotient is. It's really similar to the equal groups that we've been working with. Very similar, but it's just another method for us to organize our work, and for some it can feel a little more efficient to use partial quotients. At times I would find it's partial quotients is a little bit easier if you're working with larger numbers. But I'm going to show us partial quotients alongside of equal groups for the first one. So you can see that really it's the same concept of math. Like we're doing things the same way. Let's just fix that all together. But we're organizing it in a way that might feel a little more manageable. So what I mean by that is we're going to start with that problem here. That's 84 divided by 4. So 84 divided by 4. And so we're going to set this up first. So again, if we're using equal groups, the technique that we've thought about is this tells me I have 4 equal groups to work with. If I'm going to set up over here using partial quotients, I'm going to go ahead and I'm going to take 84 and I'm going to put it into this division symbol, and it's an altered division symbol. This is what a lot of times people will call the big 7, because you can see it looks like a big old 7 I put there. And then we're dividing by 4, so that's going to go on the outside of the box. So there's just the setup right now. As you can see, it looks different, but again, the process is very similar. If I was doing equal groups, right, I would be thinking about, okay, well now I'm going to take this 84 and I'm going to distribute it into these one at a time, right? And we've counted by ones, and we talked about how sometimes that doesn't go as well, right, when we count by one. So we could also be thinking about counting by 2s, skip counting by 5s or 10s, right? And we're just kind of making groups as we put in there. If we think about partial quotients, it's actually very similar. That this, I'm thinking about groups. But I'm thinking about those groups of 4, right? Here, we were just like skip counting, like 2, 4, 6, 8, or 5, 10, 15, 20. But here, we're actually going to literally think about what it is to take those groups and multiply by 4. And we want to use some basic facts we know to help us. 4 times 1 is 4. Like we know that. That's the identity property of multiplication. And if I know 4 times 1, then I know 4 times 10, right? That's that base 10 multiplication we've talked about. And that's going to get me 40. Right? And if I know 4 times 2 is 8, then I know 4 times 20 is 80, right? So those are some groups I could be thinking about. Now let's jump back over to equal groups and think about, okay, well, what would we do here, right? This is a familiar process. So let's see, what would we do here? Maybe we want to count by 10s first. So let's go 10, 20, 30, 40, right? Okay, so we'll stop there and we'll jump back over to partial quotients. We started with the groups over there. Let's do the same thing over here. Let's look at what we just did there. We could start with the same thing. We could start with this 10 here. We could say we're working, I don't like how skinny that is, hold on. We're working in groups of 10, right? Because 4 over here, oh my gosh, show up, 4 times 10 equals 40, right? And then I'm just going to subtract that, right? I use this fact over here. I said 4 times 10 equals 40. I'm going to subtract that. I have 44 left, right? And so there's like a group. So over here, let's jump back to equal groups. We're kind of doing the same thing, right? So we said 10, 20, 30, 40. Let's do another group, 50, 60, 70, 80, right? So we're at 80, we need to get to 84, so we can do some more groups. But before we do that, let's jump back over to partial quotients. So I have 44 left. What's another group I could work with? Well, I could actually do another group of 10, just like we did in the equal groups, right? We did another group of 10 in each circle. This time again, there's like 4 circles. 4 times 10 is 40. And if I subtract, I have 4 left. So let's just finish partial quotients out. That means I need, if I have 4 left, I only need to do 4 times 1. And that would get me 4, and I'm at 0. And I can just add up my groups that I have over here. This is just like as if this was where the circle was of equal groups. So this is 21. So my answer is 21. So let's finish things out over here next door with equal groups. So we said 10, 20, 30, 40, 50, 60, 70, 80, 81, 82, 83, 84. So we did it. So let's just count what's in one circle. 10, 20, 1. There's 21. So you can see, I hope that made some sense. I tried to like kind of make them parallel. The partial quotients is really the same idea as equal groups. We're just doing it in a different format. Now, I know that was a lot. That was a ton. So I'm just going to stick strictly to partial quotients for this one. And I want you to see what I'm doing, right? So again, we're just going to set up the problem. We don't need circles for this one because it's a different method. So we're going to take the number divided by, and then we're going to put 6 on the outside here. And that 6, it represents like those 6 circles, right? It's those 6 circles, and then how much will we put into each circle? Well, if I think about that, I can use my math facts, my multiplication math facts, to think about groups I want to start working with. So let's see, 6 times 1, that equals 6. 6 times 10, that equals 60. 6 times 2 is 12. So 6 times 20 is 120. Okay, so again, partial, right? Partial quotient, partial. So, oh, excuse me, partial. So this is where, stop that. This is where we are going to take what part we want to work with. And I always want to think like which one of these over here is closest to where we're starting. And I noticed that 120 is really close to 132. And that just means then I had 20 groups of 6, right? Do you see that? So it's like 6 times 20 equals 120. And then we're going to subtract, because we've used that. We just made 20 groups of 6, right? We just made 20 groups of 6. It equals 120. So we're going to subtract it from the 132 that we have. And we got 12 left. I'm going to get rid of a few of these little lines so they don't confuse us. Okay. All right, so now, as we go back into this work here, we have 12 left. Well, if we look at my facts over here, 6 times 2 equals 12. So 6 times 2 equals 12. And I can subtract. I have nothing left, so I know I'm done, because we always want to work to 0, right? Because that means I don't have any more to put into circles or into groups. Let me just add this up. Just like we would, like if this was the circle with those equal groups, we're just adding what's in the circle. And what's in this one is a group of 20 and a group of 2. So that's 22. So 132 divided by 6 equals 22. Okay? All right. Again, don't stress it. Just keep watching, keep practicing. I'm going to put another problem up. And if you want, you can try to dive into it, right? Always pause and try to solve. And then come back and watch. So 215 divided by 5. Okay, again, we're going to use partial quotients. Let's just make that clear. Partial quotient. So we're using groups and parts to solve a division problem. So I'm going to take 215. We're going to put it into that, what people refer to as a big 7, but it's really just like a way of organizing our division. And we're going to divide that. I'm going to really try to be extra color coded with this one by 5. Okay. So to help me start, again, I'm thinking about these groups of 5. I'm thinking about my multiplications of 5 to help me get to 215, right? Same thing as if I was doing those circles and I was counting out 1, 2, 3, 4, 5, right? So 5 times 1 is 5. If I know 5 times 1, I know 5 times 10, that's 50. If I know 5 times 2 equals 10, 5 times 20 equals 100. Let's see, 5 times 3 equals 15. And see, I'm still kind of just doing this to make a list of numbers I could use. was 150. Okay, so I could start there. I could also add more facts, but I'm just going to look now and say, looking at this list, right, which one of these answers is really close to 215? And I like this one at the very top now, where it says 5, right? There's my group of 5 times 30. Times 30. So I'm going to put the 30 on the outside, and that equals 150. So that's how much we're going to take away from what we have. So boom, let's see, the bottom is too big, so we're going to decompose. That makes this a 6, and that's a 0. So we have 65 left, right? So then we can go back over to our list and look like which one of these is good. And I see this 50 here. This one's close. I like that. So I'm going to use that. So that was a group of 10. So the 10 goes here, right? And that equals 50. And we subtract, and we have 15 left, okay? And then if I think about my list over here, right, that is going to be a group of 3 equals 15, and I subtract and I get to 0, right? That's my goal, get down to 0. Once I'm at 0, I add up what I have over here, and that's going to be my quotient, right? That's the answer. So 343, so 43, okay? So partial quotients, right? Like, again, we're going to keep practicing this. I don't want you to stress. Here's one more. Let's take 248. And again, on this one, really, I'd say really pause this one and go through and do it and then come back. So we're going to take 248. We're going to divide it by 8. All right. So you've come back from pausing. I know you have because you tried this out. And here we go. I'm going to go and set up. We're going to take 248. And I'm going to divide it by 8. Now, to help me again, we're going to think about those groups of 8. We're going to use multiplication facts of 8 to help me, because I'm going to make groups, right? Equal groups. So 8 times 1. So one group of 8 equals 8. 10 groups of 8 equals 80, right? What if we did 3 groups of 8? Well, that's 24. See what I'm into right here? Because look, that means 30 groups of 8 is 240. And I like that one, because if we start there and say we're going to take 30 groups of 8, that equals 240. Look how close I am to being done already. We're just going to subtract. We have 8 left. Well, that just means I need one more group, because 8 times 1 equals 8. I'm at 0, so I just add these up. I get 31. Okay? So this is the whole idea about partial quotients. And I hope this helps. I hope that you see from earlier, like, its relationship to equal groups. Really, it's just another way to be organizing. And I hope, again, you're still making that great connection on how important it is that if I know my multiplication facts, I know how to divide, right? So let's keep up the good work. I thank you, right? Just keep trying these things out. Ask questions, post questions, and we will see you at our next video.